All right, hello. Welcome to this video for pre-calculus on your off-campus learning day. We're picking up right where we left off with triangles, but the question that leads our discussion on this worksheet is, what if you're trying to find the sides or the angles of a triangle that is not a right triangle? Okay, if it doesn't have a right angle, you can't just use SOHCAHTOA like we have been using the last few days. Okay, that no longer applies. So we're going to talk about two things that we touched on Friday: law of sines, law of cosines. I'm going to do a few examples, and you should use this video to help you solve the rest of the problems. Feel free to pause because I'm going to go through quickly, and since it's a video, you can always pause, rewind, hear things over and over again. So I will try to keep this video short and let you slow it down on your own pace. Okay? There are two formulas. Law of sines is side A of the triangle over the sine of angle A should equal side B of the triangle over the sine of B, which should equal side C over the sine of C. And we use this if we're given two angles or three angles, right? So if you're given a triangle, like take a look at number 1 right now, we have two angles. We have 19 and 110, and then we have one side 14. But the kicker here, you always use law of sines. If you can get an angle and the side that it matches up with, then you know you use law of sines. Okay? Law of sines will help us find this angle and then these two sides, lowercase b and lowercase c. Here's how it works. Since we have angle A and side A, I can use those two to make a ratio. Side A over the sine of angle A should be equal to side B, which we do not know, but we do know angle B. Okay? And we actually know sine A. Angle A is 110 degrees. So we have a complete proportion on the left, and we're solving for B on the right. So then we will just cross multiply, and we will get sine of 110 times B is equal to whatever 14 times the sine of 19 is. Okay? So you're taking your calculator here. Make sure it's in degree mode. I'm typing 14 times the sine of 19 in, and I get 4.558. I'm going to divide that by the sine of 110 so that we'll have B equals something. So I'm doing 14 sine of 19 divided by sine of 110. And I get 4.85 for little b. So little b is 4.85. We knew when we started, we knew that capital A was 110. We knew that B was 19. And if we do 180 for a whole triangle, minus 110 minus 19, we know that this last angle is 51. Okay. We also knew that side A was 14. So literally all we had to find was side B and C. We just used law of sines to find B. Okay. And now we have to use law of sines again to find C. Pythagorean theorem does not work for these triangles. Why? Because it's not a right triangle. So we have to use law of sines again. So what I'm going to do, I'm going to switch to green here. I'm still going to use this, but I'm going to set it equal now. Since we're looking for side C, I'll put side C over the sine of C, which is 51. We cross multiply again. Okay, cross multiply, cross multiply. Okay, I'm going to cram my work over here in the left corner. We get sine of 110 times C equals whatever 14 sine of 51 is. So in my calculator, I'm going to type 14 sine of 51 and then divide that by sine of 110, and we get C equals 11.578. That is the law of sines. You use that when you're given two angles or three angles, or more importantly, you use that when you have, you just see me circle that in yellow, when you have a side, 14, that matches up with an angle, when you have a complete proportion. Okay? So that's law of sines. Law of cosines is what I'm going to show you next. There are 3 formulas for law of cosines. They are a little more complex, and you use this when you are given 0 or 1 angle. Okay, when you don't have a proportion that matches up. Here you go. Remember, lowercase letters are side lengths. A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Notice that this side matches this angle. That's how the formula works. So if I were to mix it up and put a B here, then this would change to A squared and C squared minus 2AC cosine of B. Notice B matches the B at the beginning. And then lastly, if we put a C out here, this would become A and B minus 2AB cosine of C. C matches the C out front. Okay? This formula is strange, but a lot of it is used on our calculator, so it's actually not that difficult. Okay? Law of cosines when you're given 0 or 1 angle. I'm going to scroll down here. We're actually going to omit number 2. We looked at that in class. I want to show you a different example, a little harder example. Okay? Let's look at 3. Okay? I have 1 angle, capital D. I have 2 sides. I have F, which is 9.5, and I have E, which is 12. Okay? So what I'm going to do is I'm going to use law of cosines because I don't have a matching pair. So I'm going to look for this. I'm going to try to find side D. So I'm going to say D squared equals, D squared equals E squared, which is 12, plus F squared, which is 9.5. And you might be thinking, why am I not using A, B, and C? It's because they gave me D, E, and F. But if you want to, you can label those A, B, and C if that confuses you. So we have D squared equals E squared plus F squared minus 2 times E times F times the cosine of angle D. Now here's the good news. That looks crazy, but we are literally going to type this exact thing into our calculator, making sure parentheses are all in the same spot. And when I type 12 squared plus 9.5 squared minus 2 parenthesis 12 parenthesis 9.5 times cosine of 50, all of that, I get something that's crazy. So let me try typing that in again. I know that's not right. Let's see. 12 squared plus 9.5 squared minus 2 times 12 times 9.5 times the cosine of 50. Well, I got the same thing again, so I guess that is right. D squared. Oh, of course it's right, because look at this. D squared equals 87.694. And I panicked for a second because I thought 87 is huge, but that's because 87 is equal to D squared. We have to square root both sides to find our actual side length. So the square root of our answer, that's more like it, 9.365. So literally I typed all of this in my calculator, this in the red box. Then when you solve for your side, you get 9.365. Now here's the good news. You only have to use law of cosines one time because look what we have now. We have a ratio of an angle and a side, and we can use the law of sines. Okay? So now I can say side A over the sine of A is equal to side B over the sine of capital B. Okay? And what do we do when you have a proportion like this? You cross multiply. Okay? So we're going to get 12 times the sine of 50 equals 9.37 sine of B. Divide both sides by 9.37, and the sine of B is going to equal whatever 12 times sine of 50 divided by 9.37. I got 0.98. And does that make sense? Sine of b is 0.98. Oh, we're looking for an angle, so we've got to use inverse sine. All of this connects from what you just did. When you are ever looking for an angle, you have to use inverse sine. So when I type that in, I get 78 degrees, and that is the angle that corresponds with 12. And how do we find our last angle? We do 180 minus 78 minus 50, and we get 52 degrees. Okay, so that's the law of cosines here. This was law of cosines. This was the law of sines over here. Okay, kind of seeing them both in action in one problem. That's how we solve triangles. Your homework is to take a look at number 4, give it your best shot. Okay, notice you have 3 sides here and no angles, so I will give you a hint. Use the law of cosines and see where it takes you. We will look at this in class, but more importantly, this is your homework here. This is your off-campus learning day assignment. Finish this, 1 through 6. Okay, see what you can do. Notice I gave you 2 gimmies. Number 4, hopefully you see that right angle. Number 1, hopefully you see that right angle. Okay, but for number 2, we're given 2 angles, so we're probably going to use law of sine. Number 3, we were given 1 angle, so we're probably going to use law of cosine. Number 5, no angles, so law of cosine. Number 6, it looks like a combination of a right angle and something else, so I'll let you figure that one out. But rewatch this video if you are unsure of how to do law of sines or law of cosines. Thank you.